Hi students, today we will discuss about a few important questions from the current electricity in board point of view. So see the first one here, the state and explain the Ohm's law. Normally they will ask for the 2 marks. So just you write the statement, whatever the statement they given, the current I to the metallic conductor is directly proportional to the potential difference between its ends, providing the temperature and other physical quantities remains constant. And after that, you write the formula V is proportional to R and V equals to I into R and explain what is V, what is I, what is R. That's all. And the next one you see here, give any two limitations of the Ohm's law. Limitations we have, I gave here three limitations. Why? Because sometimes they will ask for 3 marks also. So any three limitations you can write. So give any two limitations means Ohm's law is applicable only for uh, hmm, applicable only if all physical quantities remains same and not applicable for non-ohmic conductors like semiconductors devices and not applicable at conditions very low and very high temperatures. So these are the 3 points. If you write, they will give the maximum marks. Okay. Next, we see the next one. Define mobility and mention it as SI units. So they are this also they asked 3 times. The mobility of the free electron is defined as the drift velocity of an electron in a plate field. SI unit is S. Okay. And the next, what is ohmic conductors? Ohmic devices, give example means the device which obeys Ohm's law are called as ohmic devices. Example, metallic conductors, resistors, voltmeters, and ammeter. Okay. And next, state Kirchhoff's law of electric network. We have two laws. One is current law, other is junction law. The algebraic sum of the currents at any junction in a circuit is equals to 0. Mathematically, we can write as delta I is equals to 0. Or if you want to write extra current enter the junction is always equals to current leaving the junction, we can write another point. Okay. Next, the second law, if we take voltage law, if we take the algebraic sum of the EMFs and voltage drops in the resistor around a closed circuit is equals to 0. So this is mathematical term is equals to, we can write delta IR plus or minus delta V is equals to 0. Later you see here, define the drift velocity. Write the expression for the drift velocity in terms of the current and explain its terms. Drift velocity Vd is equals to, in terms of the current they ask. In terms of the current means Vd is equals to, right, or otherwise we have the another form. I is equals to N E A Vt. So this is the derivation we have. From this we can write Vd is equals to I. What is I? What is N? What is E? And what is area of cross section? If you explain each and every term, they will give the maximum marks. Okay. Now, after that, what is how the variation of resistivity with absolute temperatures in case of copper and nichrome metals. So this is copper, this is nichrome metals. Okay. So be careful while draw the graph. Graph, okay, if you write by mistake the names is reverse ways, they will cut the marks. Okay. Right. Next one. Sometimes its marks is not important, just you focus on the questions here. Derive an expression for the drift velocity of the free electron in a conductor in terms of relaxation time. In terms of relaxation time, they ask. See, so this is the diagram we should draw. After that, acceleration of the free electron formula, we have A is equals to F by M from the Newton's second law. So this equation. Then after force acting on the charged particle formula, F is equals to minus E into E. And after that, equating these two equations and find out the acceleration, you can write the equation number 1. After that, what is the first equation of motion we have? V equals to E plus AT. And here, V we can replace with the different. This is we can write VD like this. Okay, VD. and T is equals to tau. This tau is called as relaxation time, average relaxation time. After that, from the equation 2, we can write Vd is equals to A into, so you just extend this font size like this. Vd is equals to A into tau. So this is the way we can write the drift velocity. So this is the final output of the drift velocity. Next, derive the relation between the current density and conductivity of a conductor. Uh, in some books, they will give it's a microscopic form of Ohm's law also. This is called as microscopic form of Ohm's law. Okay. See again here, current formula from the Ohm's law, I equals to V by R. And after that, we know the formula R is equals to rho L by A. We can take that R formula here in this equation 1. After that, we can make some modifications and VL and all. And we can write, see the current density formula, we know that J is equals to I by A and conductivity is equals to what? Reciprocal of resistivity. Then V by A. So we have the relation between electric field and electric potential in the potential and capacitance chapter. From that, we can take this form. Okay. After that, equating these two, we have this we call as microscopic form of Ohm's law also. Okay. Now see here. Next one. So this is one formula. Just to write as it is, you will get the maximum marks. Okay. If you want, you can write one diagram also, conductor and electric field. Okay. Right. Next. Assuming the expression of drift velocity and derive the expression for the conductivity of your tensor. This is one of the very important quiz. So just another ways they ask rho is equals to N square tau by M. So here Vd is equals to drift velocity, V is the potential difference of the wire area of the cross section, N is the number of turns per reluctance. So take basic formula. This is only the given expression for the drift velocity. I is equals to NEAVD. After that, we know that drift velocity formula, magnitude of the drift velocity, NEE by M into tau. That we take here. Okay. So this drift velocity, they are replacing with this. So drift velocity is equals to E by M into tau. Now after that, you just do the multiplication and E square is there. And you write as is this E into E, it becomes E square and tau by E. And after that, we have the formula. This is current density. Current density J is equals to I by A. So I we have here, by A we can take here. And if you do the simplification, this is the final output. Okay. So this is very, very important. Guys, you have to focus. This is very important relation we have. Okay. So everything is important in that. This is also important only. So whatever the questions is there here on the screen, everything is important. Try to learn all the questions to get the maximum marks from this chapter. Okay. Next. So I move for the next one. So this is the derivation. So next one, if you see this they can ask for 5 marks. Two cells connecting in parallel. So cells are connecting in parallel. Check the diagram. Easy diagram we check. Input current and output currents. After that, yes, this is the correct diagram. Okay. Now see here. First, we should find out the by applying the junction law, I equals to I1 plus I2. This is I. That is splitting of the two parts and output current also it becomes I. So I equals to I1 plus I2. So that is equation number one. And both the cells having the two internal resistance. Okay. So here you can write let or otherwise consider two cells. You can write two cells of EMF E1 and E2, R1 and R2 resistance. Okay. First, we should find out the terminal voltage and potential difference across the first cell. This is the second equation. Potential difference across the second cell is the second equation. Now, equation 2 and equation 3, if we take. Okay, so diagram. After that, these three equations. Later, we can write I equals to E1 minus V by R1 plus E2 minus V by R2. Now, splitting these terms, here will come plus some. Okay? So, E1 plus E2. Okay, I1 is equals to this is and otherwise they can split also. V by R1 minus V by R2. So later this step from here. Okay. This. Here minus is there. Okay. Right. Next, after you see, so these are the various steps. Step by step, you should learn. And finally, they ask what is voltage, terminal voltage and potential difference. V equals to parallel combination of cells is replaced by a single cell. E equivalent or R equivalent. Then so this is E equivalent. This is R equivalent. This. Okay. The last final one here. This is very, very, very important. Okay. So time the next question for the balancing condition they ask here. So consider four resistors P, Q, R is connected in the form of Wheatstone bridge as shown in the diagram. And after that, applying when the Wheatstone bridge is balanced, I is equals to 0. Apply the loops for the mass ABDA and I1P plus Ig into G minus I2 into R equals to 0. And I1P minus I2R is equals to 0 this. After that, apply the mesh rule for the BCD. You can write this equation. In between, if you want to apply the junction law also, you can apply the junction at the B and D also. Okay. Then after that, you write these equations like this. Okay. Thank you very much. That's all for today. Okay. Bye.